Space, the final frontier, an endless expanse that stretches beyond our wildest imaginations. It's a realm where time and distance lose their meaning, and the very fabric of reality seems to bend and twist, a canvas of darkness sprinkled with glittering stars, each one a beacon of light, a distant sun with its own story to tell. They twinkle and shimmer, creating a mesmerizing tapestry that has captivated humanity for millennia. It whispers tales of cosmic wonders, of celestial dances and violent births. Stars are born in fiery explosions, live out their lives in a delicate balance of forces, and die in spectacular supernovae, leaving behind remnants that continue to intrigue and mystify us. But beneath its shimmering beauty lies a silence so profound it's almost deafening. In the vacuum of space there is no air to carry sound, no atmosphere to diffuse light. It's a place where silence reigns supreme and the only sounds are the ones we bring with us. No air to carry sound, no atmosphere to diffuse light, just the faint hum of the universe, a symphony heard only by the soul. It's a silence that can be both terrifying and awe-inspiring, a reminder of the vastness and mystery of the cosmos. Just the faint hum of the universe, a symphony heard only by the soul. Imagine yourself adrift in this silent expanse, the earth a distant pale blue dot. You are alone, yet connected to everything around you, a part of the grand cosmic dance. Imagine yourself adrift in this silent expanse, the earth a distant pale blue dot. Your thoughts become your only companions, and the silence becomes a canvas for your imagination. You ponder the mysteries of the universe, the nature of existence, and your place in the grand scheme of things. Your gaze falls upon a point of light, seemingly insignificant amongst billions. It appears calm, serene, but as you focus you realize that this tiny dot holds secrets beyond comprehension. It is a white dwarf, the remnants of a star that has exhausted its nuclear fuel and collapsed into a dense compact object. This, my friends, is a white dwarf, a stellar remnant that defies our understanding of physics and challenges our perceptions of the universe. It may be small, but it is incredibly dense, with a mass comparable to that of the sun, packed into a volume similar to that of the Earth. Don't be fooled by its diminutive appearance. A white dwarf is a powerhouse of gravitational forces, with a surface gravity hundreds of thousands of times stronger than that of Earth. It is a testament to the incredible processes that govern the life and death of stars. It harbors secrets of stellar death and unimaginable forces. In its silent, unassuming way, it tells a story of transformation, of the relentless march of time, and of the enduring mysteries of the cosmos. The silent symphony of space continues, and we are but humble listeners striving to understand its profound beauty. Stars, like us, have a life cycle. They are born from vast clouds of gas and dust, known as nebulae, which collapse under their own gravity. Over millions of years, these clouds condense to form a new star. They're born, they shine, and eventually, they die. During their lifetime, stars undergo nuclear fusion, converting hydrogen into helium and releasing immense amounts of energy. This process is what makes stars shine so brightly in the night sky. A white dwarf is the leftover core of a star, like our sun, after it has exhausted its nuclear fuel. When a star like the sun reaches the end of its life, it expels its outer layers, leaving behind a hot, dense core. Imagine the sun, squeezed down to the size of Earth. Despite its small size, a white dwarf retains much of the sun's mass, making it incredibly dense. That's the density we're talking about. A single teaspoon of white dwarf material would weigh as much as an elephant on Earth. As a star ages, it sheds its outer layers, painting the cosmos with vibrant nebulae. These nebulae are the remnants of the star's outer material illuminated by the remaining core. The core, however, contracts, its atoms crushed together by gravity. This process increases the core's density and temperature, leading to the formation of a white dwarf. This creates an object of incredible density, a stellar ghost still radiating heat from its former glory. Over billions of years, a white dwarf will gradually cool and fade, becoming a cold, dark remnant of a once brilliant star. Imagine Earth's gravity. Now multiply it by hundreds of thousands. That's the kind of pull you'd experience near a white dwarf. A single step on its surface would feel like carrying the weight of a mountain. Your bones would buckle, your organs would be crushed. Even light itself bends under such extreme gravity. The very fabric of space-time warps around a white dwarf, a stark reminder of the awesome power these stellar remnants possess. Meet Chase, a veteran astronaut on a mission to study a nearby white dwarf. With years of experience under his belt, Chase is no stranger to the vast, uncharted territories of space. His journey has taken him to the far reaches of the galaxy, but this mission is unlike any other. Imagine the thrill, the fear as his ship, the Phoenix, approaches this celestial enigma. The white dwarf, a remnant of a star that has exhausted its nuclear fuel, is both a scientific marvel and a potential hazard. The Phoenix glides through the void, its sensors capturing every detail of the star's intense radiation and gravitational pull. His heart pounds as data streams across his monitor surface temperature, tens of thousands of degrees, gravity unbearable. The numbers are staggering, almost beyond comprehension. Chase knows that one miscalculation could spell disaster, yet he remains focused, his training kicking in as he analyzes the data, searching for patterns and anomalies. "This is Phoenix to base!" Chase's voice crackles over the comm system, approaching the dwarf. "Readings off the charts. But it's beautiful." His voice carries a mix of awe and apprehension. The white dwarf's brilliance is mesmerizing, a stark contrast to the cold, dark expanse of space surrounding it. Like a diamond in the black. Then, silence. The beauty of the star is almost otherworldly, its light piercing through the darkness like a beacon. Chase is momentarily lost in its splendor, forgetting the dangers that lurk just beyond the ship's hull. The transmission cuts out, leaving only static and unanswered questions. What happened to Chase? The silence is deafening, a stark reminder of the isolation and unpredictability of space. As Mission Control scrambles to re-establish contact, the fate of Chase and the Phoenix remains a mystery, shrouded in the cold, unfeeling void of the cosmos. Section 5, A Sea of Electrons, Defying the Crush. To understand Chase's fate, we need to delve into the heart of a white dwarf. Here, gravity attempts to crush matter out of existence, but a peculiar force fights back: electron degeneracy pressure. Imagine electrons, those tiny particles orbiting atoms, being squeezed together until there's no space left. They resist further compression, creating an outward pressure that counteracts gravity. This delicate balance prevents the white dwarf from collapsing in on itself. The immense pressure within a white dwarf can crystallize the carbon atoms in its core. Yes, you heard that right. A giant diamond. Imagine the sparkle. A cosmic jewel forged in the heart of a dying star. But don't let the beauty fool you. This diamond is deadly. Its surface seethes with leftover heat, radiating intense X-rays and ultraviolet light. Remember Chase? As his ship neared the white dwarf, the immense gravity began to stretch his body, a process scientists call spaghettification. But that was just the beginning. Before he could become a human noodle, the intense heat vaporized him, turning him into a cloud of atoms scattered across the stellar surface. The silence of space had swallowed him whole. The story of white dwarfs doesn't end there. Some of these stellar remnants aren't content to simply cool down. They pull in matter from nearby stars, adding to their mass. If a white dwarf eats too much, it can trigger a runaway nuclear explosion, becoming a supernova. But there's another, even stranger possibility. If the white dwarf is massive enough, it can collapse further, crushing the very electrons that once held it up. This would give birth to something even denser, even more extreme, a neutron star. The universe is a place of endless wonder, filled with objects that challenge our understanding of physics and reality. White dwarfs, those unassuming specks of light, offer a glimpse into the life and death of stars, and the incredible forces at play in the cosmos. So the next time you look up at the night sky, remember Chase and his ill-fated mission. Remember the silent symphony of space, and the secrets it holds. The universe awaits, full of mysteries waiting to be unraveled.